Hi everyone, this is Advanced Statistics for the Social Sciences. In this lecture, I'll describe the process of statistical inference through null hypothesis significance testing, the concepts of type 1 error, type 2 error, and power, and the process of comparing a calculated statistic to some fixed parameter. Let's begin by talking about significance testing. So far in these lectures, we've talked about the normal curve, computing z-scores and using them to find the probability of score occurrence, the sampling distribution of means and how to use it, estimation and inference, and hypotheses. All of these things are used together in the process of null hypothesis significance testing. We're finally getting to the part where we'll learn the steps that we will take to test our hypotheses. This is the traditional way that we conduct statistical tests of significance. Remember, the goal of null hypothesis significance testing is to infer something about the larger population from our smaller samples results. Hopefully you have learned about validity and reliability in research methods. Validity is asking, does your measure accurately correspond to what you are attempting to measure? For example, are your questionnaire items or your lab observations capturing what you think they are capturing? An example would be if we are asking depression questions on a survey, are those questions actually measuring people's depression or are they measuring anxiety instead? If they are measuring depression, they would be valid. If they were measuring anxiety, they would be invalid. An extreme example of bad validity would be if you had a thermometer meant to measure temperature, but it actually measured weight. Reliability is the extent to which a measurement gives consistent results. For example, assuming depression is stable, if you take the depression test today, you should get the same score tomorrow. That would be a reliable measure. An example of bad reliability is if you put an object on a scale and it said 50 pounds, and you put it on again 10 minutes later and it said 52 pounds, even though the weight didn't change. So, when we are learning about inference and we're developing research questions and selecting our samples, it's important to use valid and reliable measures with those samples. Again, the goal is always to use the sample to make a decision about the population. And later in this lecture, we'll go through the specific steps. But for now, we know that we need to make a decision. And those two decisions could be to either fail to reject or retain the null hypothesis, or to reject the null hypothesis. For this example, here's a scenario we might use null hypothesis significance testing for. We might hypothesize that when teachers are bold, they will be better teachers. So we create an intervention to increase teachers' boldness. We sample some teachers from the whole population of U.S. teachers and give all of them the intervention. And then after the intervention, we measure boldness in the teachers. So let's say that the boldness mean for all teachers in the U.S. and the population is 0. This would be our null hypothesis. Let's say the boldness measure has scores that range from negative to positive numbers. We expect that our intervention will increase boldness, so we expect their scores to be more than 0. As we have discussed several times, when we're working with a sample from the population, we can't be 100% sure that we're right about our estimates. Our estimates come from the sample, and typically they're a little bit off from what's actually happening in the population. This means that we might also be off in our decision to reject the null hypothesis, or we could make an incorrect decision about the null hypothesis. So, what if my sample had a random difference, for example, due to some poor sampling on my part, that didn't exist in the true population? For example, I might try to randomly select my sample in this example of teacher boldness, but the group of teachers that I selected for my program had lower boldness than teachers typically do in the population. Another example could be if there was an unknown source causing some difference in the study, which I didn't account for. So in this teacher boldness example, an example of this would be before our teachers complete their boldness questionnaires, the experimenter was overly friendly to the teachers. And so this led the teachers to feel more comfortable and then in the situation and then increase their boldness measures on their questionnaire. So there are always things that you can't control, and you don't know if those things that you're not controlling will make your estimate too small or too large. This concludes the first lecture on inference. In the next lecture, I'll describe type 1 error, type 2 error, and power.